Welcome everybody to yet another XSharp online session. Today we will have a look at XSharp and future.NET versions. And with future.NET versions, we mean .NET Core, the latest versions, and .NET 5. On the next slide, you'll see today's agenda. First, we'll have a look at the current situation. Where are we today with regard to .NET versions? And then we'll continue to look at what has changed for .NET Core and .NET 5. We'll have a bit of a detailed view at the build system and how you can deploy the .NET 5 as a single exe. Finally, we're going to look at the VS integration and the changes that you have to make in your code. Okay. At this moment, I see that there's 4 different versions of the .NET framework side by side, and I know this has caused a lot of confusion. When Microsoft started with .NET, they sort of designed let's say a description of how an ideal development environment should look like. And the description is what they have deposited with ISO and make the .NET standard, the .NET rules, basically. You could call it, as a developer, you could see that it's like an interface. And in reality, there were 4 different implementations of this .NET rules of this interface. And that the most common one is .NET Framework on Windows, but next to that there was Xamarin, which was targeted at mobile devices, Mono for Linux, and the Universal Windows Platform was also a bit of an implementation of .NET Framework for applications developed for Windows 8, basically the Windows 8 UI. Microsoft didn't like the idea that there was 4 platforms side by side, because there's a lot of duplicate code and not all code was optimal. And when they acquired Xamarin, they decided to develop .NET Core with the idea to join these 4 platforms into one code base. And it was a long journey. And in the meantime, they came up with something called .NET Standard, which is like a way to describe common behavior for various platforms. So if you were a third-party developer and you developed for a certain level of .NET Standard, you knew that your library would be usable both in the .NET Framework and Xamarin, for example. So .NET Standard was like a subset description of functionality that exists in various different implementations of .NET. Unfortunately, .NET Standard came with this very complicated table of versions, and I'm not sure if any of you looked at this, but on the top you see the different .NET Standard version numbers, and then it starts with 1.0 and ends with 2.1, and on the bottom you see under it you see the different versions of the framework, and this was like a mess. So .NET Standard is a way for third-party developers to create something for different platforms, but it didn't really help. I think it's a mess. So in this list you also see mentioned .NET Core. .NET Core actually was created as an idea to merge these 4 frameworks into one platform. So at this moment we have reached the stage where .NET Core 3 is in production, and Microsoft is now working on the next version of .NET Core. They sometimes call it also .NET Core Next, and that next version of .NET Core is actually going to be called .NET 5. And the idea of .NET 5 is that it will replace the .NET Framework, it will replace Xamarin, it will replace Mono, it will replace .NET Core. So all these different versions of the framework will become merged into one version. From what I see, the biggest difference is what the 3rd bullet here says, is that .NET Framework is global. So if you install .NET Framework on your machine, all your apps will work with the same version, where .NET Core allows you to deploy different versions of that .NET Core side by side. So For example, if your app is developed for .NET Core 3 and Microsoft comes with .NET Core 5, any breaking changes they do for .NET 5 will not affect your .NET Core 3 app. So that's the idea. .NET Core and also .NET 5 will therefore not use the global assembly cache. And this is really a big thing because at this moment, if you're a developer and you've installed the latest version of Visual Studio, you will probably have .NET Framework version 4.8 on your machine. But if your customer doesn't have 4.8, how can you make sure that you're not introducing functionality in your app that doesn't exist on your customer's machine that's, for example, 4.6? Now, with .NET Core and .NET 5, you don't have to worry about it because you'll deploy the right version of the framework or of the runtime, basically, with your app. Let's have a look at how things are working at this moment. So I'll switch to software. So let's go to another screen. Okay. Let's move some things away. Right here is, for those people who haven't seen it before, is XIDE. And I've created a small 3-line application in XIDE which is an application, and in the properties you can see it's a console application, and it has a reference to only a system DLL. When I compile this on Windows, this is always Windows, and I run it, I will see the output that says, hello XSharp world from 40.33.19.42.000. This doesn't tell me that this is 4.8, but I know this is .NET Framework 4.8. When I develop my app, the compiler is called to build the app, and the compiler gets told which assemblies to link in the app. So let's change, let's create what's called a response file. Actually, I've done that before. This is what XIDE sends to the XSharp compiler. So it says there's a folder with the source file. It references Windows, Microsoft.NET, assembly, get, blah, 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 4.0. This is the system DLL. So XIDE generates a command line that links to the current version of the .NET runtime installed in the GAG. This works, but has a potential problem that if your customer doesn't have 4.8 and I accidentally use, let's say, a method of a string type or something like that that doesn't exist on 4.6, then the app will not run on the customer's machine. So I know many people love XIDE, but I think this is one of the weaker points of XIDE. Let's have a look at Visual Studio. Okay, open solution. Good. Here is the same code in Visual Studio. Now, if you go into Visual Studio and you go to the properties dialog of your application, you can see that you can specify the version of the .NET framework that you want to run. Now, in this particular situation, I have told it to run on 4.7.2. So I'm going to build the app. Okay, now of course the question is, what did the compiler do? Did it work just like XIDE and take system DLL out of the global assembly cache or not? A trick that you may not know, but which I want to show you, is that if you work with XSharp, you will find in your temp folder a file called last XSharp response file.rsp. And this file contains the command line that was sent to the compiler. Now, as you can see, there's a difference now. Instead of compiling against system in the global assembly cache, the application gets compiled against the system DLL and two other DLLs in the program files, reference files, Microsoft Framework, .NET Framework 4.7.2 system DLL. So the difference between what we saw in XIDE, here you see it again in the editor, is that it uses another assembly. If you run the app, let's run it in the debugger. I'm not sure if you can read it, but come on. It also says 40.33.19.42,000. And if you look in the debug window where you can see which modules were loaded, then you can see that even though I linked it to a file in the reference folder, the application itself runs against the global assembly cache, just like the XIDE app, because the .NET Framework is global on your machine. So why do we have this 4.7.2 reference assembly folder, and what kind of difference does it make? Well, the reference assembly folder describes a subset of what is supported in the current version. So on my machine that's 4.8, the subset that was available for 4.7.2. And by doing that, you cannot compile and include method calls or properties that don't exist on an other version or an older version of the framework. And for example, if I would change this to, let's say 4.0, yes, I know I changed it. Then you'll see that the response file now has a link to files in the 4.0 folder. And I know for sure that my app will not include any calls that do not exist on 4.0 and that were introduced in 4.8. Now the result is still the same. So the version number that it displays is still the higher number. Let's do the font a bit bigger. So it still says 33.19.42,000. So the difference, what you see then, is that Visual Studio actually makes sure to link against the proper a reference assembly, and a reference assembly you should see as an assembly that contains just metadata of all the public types in a certain class library, and there's no implementation of code whatsoever. So these reference assemblies are also smaller than the actual assemblies that are running at runtime. Now, why do I tell all of this? Because we will see the same happening for .NET Core. Okay, let's switch my screen back again. Good, so, okay. To summarize, Visual Studio binds to a file in the reference folder, and XIDE always binds to the get. The idea behind the different assembly locations is what I mentioned on the way, is that you can assure that your app doesn't call anything. Now, how likely is it that you introduce something? Well, I had, for example, experience with a customer's project where we were working with Vulkan in the past. Vulkan used the same mechanism that XIDE uses, and we were calling a method on the property info class in the late binding code, so we could read a property late bound. And unfortunately, we were using a method that was only available in 4.6, and at that time we said that our application should run on 4.0, and it didn't run on machines before 4.6 because this particular method didn't exist. the way Visual Studio does it and the way we have implemented it in XSharp and Visual Studio, we make sure that your app uses only the things that exist on that version of the framework that you specify. Good. What does Visual? Let me quick look at Visual Studio again. Switch. As you can see, Visual Studio, this is a fairly complicated file, but in this, the last time I compiled it, I compiled for version 4.0, and this particular version number somehow magically by Microsoft Build gets translated into the location in the reference assemblies folder. So if I change this to, what was it, 4.7.2? Let me see, 4.7.2. Then, and I reload it. Then if you look at the references list here, you can also see that it should show me in the properties window a location in the 4.72 folder. It's too long, but you don't see the whole tooltip. But this is the 4.72. So this number gets translated. This lookup, we don't do it. It's Visual Studio basically that does it. Unload it again. In this file, you will see an import, this particular import, and also this particular import. Make sure that support code from our compiler, our build system gets loaded, which then in the end resolves this reference, and the reference is somewhere, let me see. The reference is here, has no DLL extension, has no location, but these imports take care of resolving it to the right folder. Okay, this is a long intro, but it was a necessary intro. We're going to look at .NET Core, so I'm going to close my solution and I'm going to open. By the way, did you know, and I know many people don't, that you can open not just solutions and source files, but you can also open folders in Visual Studio. This is what I'm doing right now. So I'm opening the folder structure, and this is a folder structure that I'll also upload to the website with demos from today. And I'm going to show you now what development for .NET Core looks like. So this is the wrong one. I want to show you a project file. So for .NET Core and also .NET 5, Microsoft, one of the complaints they got is that this project files were way too complicated, and they want to simplify things. And this is now the new project file format. If this was a C# project, then this particular line and this particular line would not even be there, because somehow in their Microsoft support folders, it automatically knows that if the project file ends with csproj, that it has to include certain files for C#. And if the project file ends with vbproj, you guessed it, it's Visual Basic and fsproj, F#. Unfortunately, we cannot, they don't allow us to include our stuff in there, so we have to have 2 extra imports here. But for the rest, you see this is a fairly simple file. In this folder, I also have a source file called program, and I can probably get rid of this. This is the same source file that you saw before. So I have a project file here, and as you can see, the target framework is now .NET 5. Now, unfortunately, I don't have a fully working version of the Visual Studio integration for XSharp. However, I have installed an extension to Visual Studio called Terminal. It's a really nice extension. I want to go to the developer command prompt. So now I get a terminal window inside Visual Studio. I can do clear screen and clear my screen. So what I would like to do now is actually build this. And from this command line, I can now call MsBuild, or I can call the .NET tool to actually build this. And I will use the .NET tool because this is what Microsoft also demonstrates, and it has a few extra possibilities that MsBuild doesn't have. So what if I would like to run this? Remember, we have a project file that says it's for .NET 5. As you can see, there are no source files included. So when I want to compile this, I can do .NET build. And of course it doesn't work. This used to work. Oh no, I'm in the wrong folder. And now it works. So, and you can see in the tree now that this .NET tool has done a few things. It has created an object folder with some targets, props, JSON files. It created a debug folder for .NET 5 and created an output file. And it's created a bin folder debug .NET 5 with the test. Now, of course, we would like to see this run. We could call the test action directly, but this also works. And we see hello XSharp world from 5.0.0. So that's the actual version of the framework that we're compiling against. Now, this .NET tool is quite a useful tool. There's one, for example, list SDKs. If you do that, you can see which version of the .NET SDKs you have on your machine. And the first group, the 2 ones and the 3 ones, are actually only .NET Core. The 5 one is .NET Core, but actually also .NET Framework. There is no .NET Framework anymore for .NET 5. So this is the .NET that runs on both on Linux, but also on Windows, and it's just .NET 5. So in this particular folder, you can actually see that. I'm not going to show you all the details of all these files, but the first time I did the build, it actually created these files which contain information about the libraries, where it needs to get the packages, so where it finds its reference assemblies, a couple of other things. It has a cache folder which has some information. This one also says which project file was used and what the unique name is. And I think it created which folders and where the packages are loaded from. Now, of course, in the previous example, we saw that there was a response file. So what is the response file now? So what was sent to the compiler? Well, we can see that again in the temp folder. And right now, if you look in the temp folder, you will see that it's not just one assembly that gets sent to the compiler, but it's, let's load this. I have a similar version in my project here. So we have 170 lines, and line 11 starts with the reference until line 161. So that's 152 assemblies that get linked, which is quite a lot. As you can see here, this particular version of the response file was when I compiled for .NET Core 3, and the one here is for .NET 5. So these are not the actual files that are loaded when you run your app. So if you would like to see what happens when you run your app, you probably need to debug. Now let's do that. Now I'm going to attach the debugger. And as you can see now, the actual loaded assemblies are not, fortunately not the 152, but these are just 3-4 assemblies from .NET Shared, blah, 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 Microsoft Core App. As you can see also, here also, the actual app, the actual DLLs that are used for running are different than the reference assemblies that are used for compiling. And over here is not just that there could be a subset, but it's also because the actual implementation of the runtime code for Windows might be different than for Linux. So these reference assemblies can be identical, but the actual frameworks that are running on machines could be different. So the mechanism for the ref assemblies takes care that you create something that will run on every platform, and then when you run it on a platform, you actually get a specific implementation of system runtime or system threading on your machine. Is this clear so far? You're all still with me? It's kind of quiet. Okay, let's continue a bit. So this particular project is now uses SDK, Microsoft Net SDK, and it's fairly simple. Let's look at a bit more difficult one. This is one that I also described on the news group a few weeks ago. The debugging tools can stop. Oh, actually, the app is still running? No. Good. So I have a version that uses an RDD system. So this particular file does a bit more. It uses a field command to specify that the code later on in this file uses some identifiers that are not local variables. I'm opening a customer DBF and I'm creating an index. I'm doing a scan and scan. I know when one of our customers posted this example code to the Fox forum, there was immediately the question of, oh, are these guys still using do while? Why is there no scan and scan? Well, there is now in this app. This is completely normal code with one exception. That is that to get this to run on .NET, we need to tell it, .NET 5, that we're using code pages. And that's because the particular DBF file is marked to be, because this contains 8-bit byte characters, and it's ANSI and has to be converted to Unicode. And based on a flag in the header of the file, we choose a different translation. So we have to specify that we need which kind of encoding we use. And in the project file, you can see that the beginning is the same, but now we have actually included the DLL names of the DLLs of the XSharp runtime that we want to include. These are not available automatically in the .NET SDK. So we have to do this. Most likely in the future, this will be replaced with something like you see on the bottom here, a package reference. So I can imagine that we replace these 4 lines, or maybe there will be more if you develop for VO. It could be an XSharp VO, or if you develop for Foxtrot, it could be an XSharp VFP there. And we could have a package reference called a package reference, something like a XSharp VO runtime. And it will then include the core, RT, the VO, the IDE, and the macro compiler. So instead of 4 or 5 lines, you would have just 1 line. This particular package reference has to be included because of the code pages. Now, let's go to the folder. And I'm compiling for .NET 5. So I do .NET. Actually, I don't have to do build. I can just do .NET run. As you can see here, it does the same thing with the object bin folder, so it creates the binaries. And now in the output you can see Windows 10 Enterprise x64. This is the version, this is the extended OS function. Framework is version 5. This is my XSharp version. The program, and this is a bit funny, we're running an exit, but the program is called test_idd_dll. The work directory, which is where the program is loaded, is the net5 folder, and the actual current directory where the customer DBF is net5idd. And as you can see, it loads the file, it creates an index, and it has scanned for everything until K. To prove that it really created the index, you can see that the index has reappeared and was just created. Now in this particular case, I've used the VO, it was a VO DBF, I've used the DBF NTX driver, which was default for VO, so that's why this last name NTX, but it could just have been CDX. There's no real difference there. CDX works just as well. So as you can see, existing code compiles and runs on .NET 5. No changes made except for one change, and that's the one with the register provided. If you don't do this, let's just give it a try, because after all, you learn most by making failures. This of course will recompile because .NET detects that the XSharp has updated, and now we see an error message saying no data is available for encoding 1252, for information, etc. You can read it. And this one, I looked it up, and this tells me that I need to include the page, and I need to set a code page provider. So perfectly normal X-based code compiles. It is the same compiler. So if you install the .NET SDK for .NET 5, you can do this too. You cannot use Visual Studio or XIDE the way you do right now, but the good thing is you can create such an XSharp file for an existing one within minutes, because you can use a sample file and just clear out everything you don't need. There's no list of PNG files, and you can just compile it. You may need to have these files, which if you want to have them, they are available on GitHub in our development repository for the compiler. And if you really want to have that, send me a message or post a message on the forum, and I'll explain to you how to install it and how to use it. For those of you who have looked at our MsBuild support in the past, I would say the attentive readers will see that we have used something different here. One of the things we didn't like is that if you have more than one version of Visual Studio on machine, we were copying MsBuild support files a couple of times on your machine, and we were duplicating the files. This makes updating also more complicated. We have changed the build system now, and our installer sets an environment variable, which you can see here, but because this just has the same environment. No, it doesn't. But this should have. Yeah. I've set an environment variable that points to the MsBuild folder, and in my build script I said, okay, take the file from this folder. So that way we do not have to duplicate all the folders. Are there any questions so far? No? Okay. Let me see. I just want to go back to my PowerPoint for a minute. Good. Okay. Ideally, and people have told us we can would like to also include the runtime, because what I didn't show you is, or what I did show you in the debugger modules list, is that it was loading the runtime from a folder in the .NET hierarchy. But like what I said in the beginning is, you can run side by side with the files in local folders. And it's probably a good idea that I show you how to do that. Forget about this, I'll just show you in code because it's much more fun. We are developers, so we believe it when we see it. Good, we're back in Visual Studio, and let's take this one. No, I'll go back to the other one. Good. I have a batch file here that will do whatever we need. So the first entry in the batch file is going to publish my project. So it's going to create a folder that we can use to do Xcopy deployment. And you will see in the folder structure here that in my net5 folder, I now have 1, 2, 3, 4, 5 files. We have a file that says this was developed for the .NET Core app. We have a file, I'm not really sure why we need 2 of these, but this is sort of the same. And now we have the exe, the DLL, and the PDB. And you can just, if you want, you can just run this file. So I could go to the folder, but this is the same that you see if you run. Oh no, let's just not do it. Okay, let's run from the Explorer. So net5, bin, debug, net5. And these guys really love their folder structures. This is my test exe, and you see it runs. But if you would open the debugger now, attach to process, you see that it still runs against program files.net shared, right? Okay. Now what we want is to have a self-contained exe. And that's what the next sample does. I can add a self-contained true, and if you do that, you have to specify for which platform. So when I call build, it's now doing a bit more because it actually has to figure out which runtime files are needed to run this on Windows x64. And now we have a subfolder Windows x64 and a publish folder there. So I think Microsoft has stock in hard drive vendors, because this is now the publish folder and it's full, so I have to. And this is now my test exe. Let's see in the debugger. Come on. And now you actually see that it takes the runtime from the Win66 publish folder. So this actually uses the local runtime, but it's quite a full folder. I think it's over, these are 224 items. That's not what I usually would like to ship to my customer. And it's also not what we actually need for this app to run, because there's probably stuff in there that's never used in this program. And what Microsoft allows you to do with .NET is to specify that you want to trim it. So let's just remove from this folder what we don't need. I should probably have cleared the folder. I don't think it will clear the folder for me, but we'll see. Oh, it actually did clear the folder. Now it's only 73 files. And of course, TextExe still works. Now, the ideal thing would be, of course, is to have everything in one file and no baggage. So I'll tell it to create a self-contained exe, and this exe should only have the files that it really needs. And as a result, you'll see that the folder now gets quite empty. Of course, this is the last thing you do for deployment. And now you see the publish folder has only these files. I must say with the previous preview, there were actually less files than this, but the app still runs. I hope. No, it doesn't. We found an issue. It would be nice if I know what the problem is. Let's go there. Okay. We probably, let's forget about the self-contained. About the trim, no. Self-contained but not trimmed. Let's try that. No. Okay, so when I tested this a few weeks ago, I was running not the preview 7, which I'm running right now, and apparently something has changed in preview 7, and I have no idea what it is. So I'm sorry about it. This used to work in the previous preview, and if I go, let's go to one folder up. Of course, this was still running. We saw that. So, okay, there is something has changed and was broken in the trimming and self-containing stuff, but .NET 5 itself just works as before. Good. What else? Let's see. Okay. I have one more example to show you because it's also nice to see that we can actually do a .NET Form app. So, okay. This is the app, the folder that we see over here. We have a form PRG. This was a standard form with a close button. We have a start program, which the normal Windows Forms application code. And I have a bit different project file. The difference here is that you have to specify if you want to develop for the Windows desktop, you have to put this SDK name in there. And on top of that, you also have to tell it to use either Windows Forms or WPF or both. In this, I just put the WPF in here because to document it, but it's just actually not needed because this app only runs on WinForms. And if you do that, then the .NET tool will actually link to a different version of the framework and will run in .NET Core command. And of course, the close button works. And let's try to run this again. Yeah. And then debug. And now you see that it loads files from the .NET Core app, which we saw before too, but it also loads some files from the Windows folder structure. So from the Windows desktop app. And this is where, for example, System Windows Forms is loaded. And if you would have a WPF app, it's also from the system WPF or whatever the name is, will be loaded from there. And you see our test folder itself is again in the bin debug.net 5 folder. Okay, good. What else? Well, this is .NET 5, but if you would like to see this run on .NET Core, now I have to know the moniker. I think this is .NET Core 3. This should run too. Oh, the app is still running. So now it should create, no, it's not, I'm using the wrong moniker. No, I should have prepared this. Anyway, but it's a question of changing the moniker should actually make it run on .NET Core 3 or .NET Core 2. Well, Windows Desktop will definitely not be supported in .NET Core 2, but it was supported in .NET Core 3. Okay. Some people were wondering if we could get this to run in XIDE. Well, I think it could be done in XIDE. Chris would have to somehow make sure that when compiling, he compiles against the reference assemblies that were listed in this SDK folder, like these reference assemblies, .NET Core app ref 500, and then when running, it needs to actually run against the SDK executable code files. And if Chris can do that, then I'm sure he will be able to do this in XIDE as well. I think it would be nice, I know Chris is listening, I see him online, if Chris could also put something like a combo box in the application properties to specify that your app runs on 4.7 or 4.6, so you can actually also with XIDE make sure that you're not introducing code from assemblies that you do not want to use. So if you want to target 4.6, you can specify that and you're not accidentally calling 4.8 code. Okay, let me see what else do I have prepared. Yeah, I'll go back to the PowerPoint. Good, VS integration. Now it's not completely ready today. Actually, I showed an early preview to the dev team this week, but I broke it when I installed a new version of something on my machine, so it's not compiling, but we are working on it. And the reason why we cannot use the old integration is because the old integration was dependent on the old style project file formats. And we created our Visual Studio integration on top of something that's called MPF, the Managed Project Framework. And Managed Project Framework doesn't support this SDK style projects. And it also doesn't support package references. So we are working on it, but unfortunately I didn't have a reliable version for this session. And well, I didn't want to introduce too many questions. It was too bad already that this publishing in 1.exe failed today, but Visual Studio crashing and corrupting the source code, I wasn't prepared for that. But it will come, and it will not be a question of months, but weeks, because we're close. Um, what I don't like is that we have to do a lot of work here ourselves. Microsoft has created the C# project system, and it is open source, but it's very difficult to use because of they are using code from other assemblies, which is internal to other assemblies, and they use some .NET tricks to expose that code to their Visual Studio integration. And if we have our Visual Studio integration, then we cannot touch that code. So this is a kind of dirty trick they've used, and it makes it impossible for us to use their project system without a lot of extra work. So we're working on it, and it is coming, but unfortunately it's not ready yet. Good. Code changes. Well, like I've shown you, if you use Windows Forms or WPF, you need to do this kind of project moniker. So you specify the .NET SDK Windows Desktop, and otherwise it is .NET SDK without, so this Windows Desktop can then be removed. And you have to use Windows Forms. That's at the project file level. Now, if you use stuff that's not considered to be standard, like for example, the code pages which are Windows specific or which at least not part of the .NET Core SDK, at this moment, you have to have references that you, for example, in this case, you register the code page provider and you have to include a package reference. And for example, if your application uses the Windows registry, you need to include a package reference to Windows 32 registry. And this particular package reference then adds support for the normal namespaces that you also use in .NET Framework for a registry function. In the we've prepared some of our runtime assemblies already for .NET Core and .NET 5, and then we had to include this particular package reference to our core assembly because the OS function that we also used in the example actually calls the registry to see the more specific version number than it gets from the .NET classes. Okay, that's it for now. That's all I have prepared. If you guys have questions, open up your mic, ask the question, or use the chat window if you have no mic, and I'll be happy to answer any questions you have. Nobody? Was it that good? Or are you just blown away? Chris, now that you've seen this, can you do this for Visual Studio, for XIDE as well?
I think I need to watch it a few times to understand what's going on. I think I need to watch it a few times first.
Yeah. Well, the real mechanism of how MsBuild or .NET, because .NET actually is a host process, it's called the .NET command line interface. It calls MsBuild in the background, but it also has this tool that zips up the etc. And how it actually finds the SDK files, I don't really know. To be honest, since I don't want to implement my own build system, I don't want to know that. But yeah, you would probably have to figure that out. But the good thing is that the source code to MsBuild is all online. So you could download the repo and for MsBuild and figure out what they're doing.
Yeah, I imagine when it becomes a bit more mainstream, it will become public knowledge what's happening. Right now we are, it's early days still.
Well, .NET Core isn't early days. This .NET Core has been around for years now, and this build system has also been around. We start looking at it now, but it's not very recent, the mechanisms they work.
Yeah, but is it many people using it already?
Yeah. The .NET Core is used for ASP.NET for web applications a lot.
Okay.
Anyone else?
Yeah, I have a question, Robert.
Yeah.
For somebody like me who is distributing software, I mean, we have some users out there I think are still using Windows XP, and so I was wondering if you could post on the forum just a simple, elegant few lines of code, and I've seen some of it here. I'm just trying to. I'm new to all this, obviously. I'm new to everything compared to most of the other people on the site, but a few lines of code to determine the .NET version that the user has installed in their machine. Just was it the lines that you posted first, or is there something else? That would be very helpful to somebody like me.
Yeah, well, what I use in this sample, the environment.version, is not going to help you. Well, it returns you a number like 4030 something, but it doesn't tell you 48 or 47. So
Isn't there a conversion? Isn't there a conversion table for that somewhere?
yeah, that's probably online. Yeah, and I'm
Okay.
sure some of us have already done that. Is there anyone here who have that kind of code in their apps and is willing to share that? No, not right now, but we'll re-ask the question on the forum. I'm sure someone has that code but needs to look it up and is willing to share that.
Thank you, Robert.
You're welcome. Anyone else?
I have a short question.
Yeah.
I heard some claims that .NET Core should be faster than .NET Framework. Have you experienced anything like this, that application becomes faster just because they run on the .NET Core?
I have actually done no benchmarks, but I know that deep down in the core, the handling of blocks of memory, they have optimizations. And but I haven't really done benchmarks, so I could say yes, but I would be lying. So I think we just need to test it. And of course, the compiler itself hasn't changed. Yeah, we can change the compiler, but what we output now, the same code is getting output for .NET Core and .NET Framework. So if there's a speed difference, it must be in the framework itself. So it must be in system DLL and MsCoreLib, etc. And I have heard that they did some optimization there, but I have no idea about the performance.
Okay,
maybe someone can write a benchmark and run it on the different platforms.
Yeah.
I'm sure people in the C# language have done that, and if the C# comparisons will be exactly the same as our comparisons. So of course they will not compare the speed of a user or a date, but if you compare the speed of native .NET types like a list of ints or a list of strings or enumerating something, that should be the same numbers in XSharp as in C#. Because under the hood we just use the C# compiler.
Okay, thank you.
You're welcome. Anyone else? Let's see.
Robert, if I see all your build settings, maybe you understand why it needs a database app to do my job.
All my build settings?
Yeah, what I do in build farms with projects for long lasting with more than 300 people worldwide.
Yeah.
And I have a database application for getting rid of all this and still know what's going on with different build servers with all these settings and platforms and .NET versions. In your case, they are .NET versions, but
oh yeah, absolutely, yeah. I can imagine
maybe
that.
that's why they pay me so much money for doing this every day.
Yeah, we have recently started to do automated builds so far of the compiler only online because we need to compile the compiler first before we can compile the runtime. And before we got that running and that we had all the dependencies loaded to the correct location, it was quite a lot of work, yeah. So it's quite a challenge. And but right now, it is, if we check in new code in the master branch, it actually builds the new compiler in 3 different configurations. It runs the compiler test suite, it runs runtime tests, so it actually is running, but it is complicated, yeah. So I can imagine that, well, I'm not saying that we don't have a complicated system, but if your system gets bigger, you really need configuration management, build management, absolutely, yeah. That's why your suggestion to do a session on the summit that we have to cancel about continuous integration and building. I really would like to hear something more about it, because it's something most of the X-based developers are not familiar with. I know a few of our larger shops, like I'm not sure if the people from RNS company are online. I saw someone before. They, Hans Jörg, yeah, they have a build system and they look at it. I think Bernard Meyer also has automated builds, but it's quite a challenge to set that up.
Automated build is only half of the rent. Let's call it
What's the
this
other
way.
half then?
Yeah, you also have an inflow with Jira tasks to describe your features. You have your change management. You have a trouble ticket system going around. What I do is I'm in the middle. I have to prove that everything what's going in is the same as it's going out.
Yeah.
And I do this on 4 production lines.
Yeah, I see a question from, this is too small. Let's see. From Andre, do you expect difficulties using XSharp DLL, VO DLL, and using the DLL with web application using Blazor? I have no personal experience with Blazor, but our assembly should just run in any CPU, and it depends a bit on what you do. There are some functions in the XSharp VO DLL that will most likely not work in Blazor, but if you don't use them, you have no problem. Like XSharp RT DLL should just work. Maybe, I can imagine maybe functions that cast pointers to something could be different, but if you stay away from that, even memmalloc and stuff like that should just work under Blazor. So PSZ should work. I don't think you will use it, but that kind of thing should all work on the Blazor. If it's just the .NET runtime that you're running against. IDD systems should run too, except if you do a web app with IDDs, you have to make sure that you have read-write access to the folder where the file is in. But apart from that, it should work. Yeah, Bernard, thank you. You have a colleague is genius. Okay, maybe your genius can teach you somehow when us all how to do Jenkins. That would be nice. I would be welcome to set up a session and have a guest speaker to do for that. It would be great. So maybe you can ask him, Bernard. Or maybe you want to hide him and then, oh, he's on vacation right now. Yeah, good. Yeah, Terry, we can read your messages, but and I understand your mic is off, yeah. Anyone else? No, if you don't, then I would like to wrap it up for now. I have another appointment at 6 and I need to prepare for that. So thanks a lot for your attention. As usual, we will edit the online stream and post it on our YouTube channel. And the link to that will be in the news group or in the forum message in a few days. Thanks a lot and stay healthy, everybody.